In electronics, a mixer or frequency mixer is a nonlinear electrical circuit that creates new frequencies from two signals applied to it. In its most common application, two signals at frequencies F1 and F2 are applied to a mixer, and it produces new signals at the sum F1 plus F2 and difference F1, F2 of the original frequencies. Other frequency components may also be produced in a practical frequency mixer. Mixers are widely used to shift signals from one frequency range to another, a process known as heterodyning, for convenience in transmission or further signal processing. For example, a key component of a superheterodyne receiver is a mixer used to move received signals to a common intermediate frequency. Frequency mixers are also used to modulate a carrier frequency in radio transmitters. Types: a device that has a nonlinear characteristic can act as a mixer. Passive mixers use one or more diodes and rely on the nonlinear relation between voltage and current to provide the multiplying element. In a passive mixer, the desired output signal is always of lower power than the input signals. Active mixers use an amplifying device to increase the strength of the product signal. Active mixers improve isolation between the ports, but may have higher noise and more power consumption. An active mixer can be less tolerant of overload. Mixers may be built of discrete components, may be part of integrated circuits, or can be delivered as hybrid modules. Mixers may also be classified by their topology. Unbalanced mixers allow some of both input signals to pass through to the output. A single balanced mixer is arranged so that either the local oscillator or signal input is suppressed at the output, but not both. A double balanced mixer has symmetrical paths for both inputs, so that neither of the input signals and only the product signal appears at the output. Double balanced mixers are more complex and require higher drive levels than unbalanced and single balanced designs. Selection of a mixer type is a trade-off for a particular application. Mixer circuits are characterized by their properties such as conversion gain, and noise figure. Nonlinear electronic components that are used as mixers include diodes, transistors biased near cutoff, and at lower frequencies, analog multipliers. Ferromagnetic core inductors driven into saturation have also been used. In nonlinear optics, crystals with nonlinear characteristics are used to mix two frequencies of laser light to create optical heterodynes. Diode: a diode can be used to create a simple unbalanced mixer. This type of mixer produces the original frequencies as well as their sum and their difference. The significant property of the diode here is its nonlinearity, which means its response is not proportional to its input. The diode therefore does not reproduce the frequencies of its driving voltage and the current through it, which allows the desired frequency manipulation. The current I through an ideal diode as a function of the voltage V across it is given by, where what is important is that V appears in E's exponent. The exponential can be expanded as and can be approximated for small x by the first few terms of that series. Suppose that the sum of the two input signals is applied to a diode, and that an output voltage is generated that is proportional to the current through the diode. Then, disregarding the constants in the diode equation, the output voltage will have the form. The first term on the right is the original two signals, as expected, followed by the square of the sum, which can be rewritten as, where the multiplied signal is obvious. The ellipsis represents all the higher powers of the sum which we assume to be negligible for small signals. Switching: another form of mixer operates by switching, with the smaller input signal being passed inverted or uninverted according to the phase of the local oscillator. This would be typical of the normal operating mode of a packaged double-balanced mixer, with the local oscillator drive considerably higher than the signal amplitude. The aim of a switching mixer is to achieve linear operation over the signal level, and hard switching driven by the local oscillator. Mathematically, the switching mixer is not much different from a multiplying mixer, just because instead of the LO sine wave term we would use the signum function. In the frequency domain, the switching mixer operation leads to the usual sum and difference frequencies, but also to further terms, for example ±3 flow, ±5 flow, etc. The advantage of a switching mixer is that it can achieve, with the same effort, a lower noise figure and larger conversion gain. This comes because the switching diodes or transistors act either like a low resistor or large resistor, and in both cases only minimum noise is added. From the circuit perspective, many multiplying mixers can be used as switching mixers, just by increasing the LO amplitude. So RF engineers simply talk about mixers, and mean switching mixers. The mixer circuit can be used not only to shift the frequency of an input signal as in a receiver, but also as a product detector, modulator, phase detector or frequency multiplier. For example, a communications receiver might contain two mixer stages for conversion of the input signal to an intermediate frequency, and another mixer employed as a detector for demodulation of the signal. See also, frequency multiplier, subharmonic mixer, product detector, pentagrid converter, beam deflection tube, ring modulation, Gilbert cell, optical heterodyne detection, intermodulation, third-order intercept point, rusty bolt effect. References. External links. This article incorporates a public domain material from the General Services Administration document Federal Standard 1037C.